All right. Hi, and welcome to the second lecture of week 4 for ISTA130, where we will talk a little bit more about loops. So what exactly are we going to be talking about? So we're going to do some more review of terminology. So we're going to talk about a lot of things that we've already talked about. Again, we'll try to go through them pretty quickly because these are things we have covered. I'm going to talk a little bit more about variables, and we are going to, the new content is mostly going to be more things about the for loops that we introduced in the last lecture, and we're going to do more of that in this lecture. All right, so small note, make sure to, when you're doing the test functions, make sure that your test functions.py is in the same folder as your functions.py. So the test function needs to be in the same folder as as your code, as your script, or whatever you worked on. So those two need to be put together. I made a short video tutorial on how to do the test function, so make sure to take a look at that. And I do mention to put those two things in the same folder, so just make sure to do that. If you're having trouble running the test functions, please get help as soon as possible. That's what we use to grade your assignments. So you be able to like pre-grade yourselves is extremely helpful and beneficial to you guys. So make sure that you have these things running right sooner than later, definitely to your advantage. Last week, we talked yet again about turtle graphics. We did a little bit more about functions, a lot of revision, and we introduced for loops. Okay, so speaking of revision, last time we talked a little bit about types, or we reviewed some of the types that we talked about. And so here's a little quick pop quiz for you guys. So if we look at these things, what types of objects do you think each of these things are? So I'll take 2 seconds, pause the video, and come up with your guesses. All right, so presumably you've made some guesses. So what kind of objects are these? So based on what we can assume, this first number over here is a whole number. And so we can assume this is probably an integer, so it's an int, or at least by default, if you assign 45 to a variable, it should by default fall into an int. This second number over here has a decimal on it, and so that would be a float. And again, can be positive or negative, just like an int can be positive or negative. Down here, this would be actually a string containing the characters 4 and 5, which is different from the number 45 over here. And we know that it's a string because it has these quotes around it. Down here, the word Freya is also surrounded by quotes, and so we know that that is a string also. And down here, we have Tulula or AZ Turtle. And so just based off of that, we know that these are variables because there's no quotes and it's a word, so we know it's a variable. And because we've basically used these before, we know that Tulula, at least, that's what I've been using, Tulula is a turtle type object, so we should know that. But realistically, these are just variables, and it happens to be a variable of type turtle. Yeah, and meanwhile, all these 4 first ones would actually be literals. So these are all literals, these are variables. And then these are 2 variables that would probably contain a turtle type object. Okay, so so here's another quick little pop quiz. Take a look at this code, and again, pause the video in a second. But just looking at this code, try to predict what you think this will actually do. By looking at this code and what we've talked about so far in for loops and defining functions, you should be able to come out with a reasonable expectation of what this should do. So pause. All right. So if you guess that this should draw a hexagon, you are correct. Not hexagon, pentagon. That's what I meant. So 5 sides, right? So how do we know that, right? So we know that we're defining a function called and we're passing a turtle and side length parameter to it. And then within the function itself, we know that we have a for loop that's going to iterate 5 times through the loop. And then each iteration is going to move the turtle forward by a distance equal to side length. And it is going to have the turtle turn right by 144 degrees. So if you look back to the previous, I think 2 or 3 lectures ago, we did some quick math figuring out angles. What we would know is that 180 minus 144 should be 36, and then 36 times 5 should give 180 degrees, meaning that basically this is a reciprocal angle that the turtle should have to turn to make the correct angles to make a pentagon. So you can figure that math out on your own on a sheet of paper. Trust me, that's right. So effectively what this does is the turtle would, on the first, when you call this function, it would call up the for loop. First iteration of the for loop, the turtle would move forward by this distance, turn 144 degrees. Then second iteration, move forward, turn move forward, turn, move forward, turn, move forward, turn. Do that 5 times. And then because these angles add up to 100, or the reciprocal angles add up to 180, it would actually form a nice pentagon, right? Okay. Indentation. So I mentioned this last time, and so here you see that the for loop is indented within the function definition, and then the for loop statements are indented within the for loop, and then there's a return to indentation here for the return. So these indents are extremely important in Python. This is how Python knows what belongs where, and so having good indentation will make your code run right. If you don't have good indentation, you are going to have problems. So here's what I mean by that. Let's do a quick little side visit to some actual Python. Okay, so so if we look over here, so I have this script over here, this little dummy script that I have set up. And in it right now, what I have is I have a for loop, and I'm basically iterating 10 times because I'm going over the range of 0 to 9. I talked about in the last lecture, and we'll come back to that in a minute, but basically it's going to iterate 10 times through the loop. And then for each iteration, it's going to print I, which again, we'll talk about that in a second, what I is equal to, and it'll print hello, hello as well, right? So if I were to guess, actually here, for now, let's keep this simple, and let's do this. All right, so right now we have our loop iterating through 10 times, and it should basically run through the loop 1, 2, 3, 4, 5, 6, and 10 times, right? And so what I should expect to see when I run this is I should see hello printed out in my console over here in my PowerShell 10 times, right? And so if I actually run it, is that what happens? Yes. So this would be the first iteration of the loop, second iteration, third iteration, fourth iteration, so on, and then 10th iteration of the loop. Loop closes out, program ends, everything did what we thought it would do, right? And like I mentioned, you see here the print is indented within for. If it wasn't indented, for example, like this, what we would see happen is, can you predict? If you guessed that you would get an error, you would be right. Right. And so here it's specifically telling you indentation error expected in indented block. And the reason for that is because in Python, whenever you have a colon like this, Python expects something to be indented. And even if you just press enter, it automatically indents it for you. It knows this about how it works. And so here it's saying, oh, actually, there's nothing indented here. There's probably a problem, right? So that's why indenting things is helpful. Alternatively, another way to think about, or another potential thing that could happen by not having your indents correctly, is, for example, say I want to print out hello you 10 times, right? So if I run this over here, so it'll print hello you, hello you. So the first iteration, it does hello, and then you. Second iteration, hello and you, so on and so forth, right? However, if I unindent this, then what should happen is, can you predict? So what should happen, if I am predicting right, is it should print hello 10 times and you just once. So is that actually true? Yes, because the U is no longer indented within the for, which means that it's no longer being repeated each time it goes through the iteration. It'll run the iteration 10 times, printing hello 10 times, and then drop out of the for, and then just print the U, which is what it's doing over here, right? So yes, that's what that's what we mean when we say that your indentation should be don't have sloppy indentation. It makes a big difference in how Python reads your code, because like I mentioned, that's how Python knows what code belongs with what else, what goes within your for, what goes within your function definition, so on and so forth. Okay, so bugs in your code. So debugging is a skill. I've mentioned this before. It takes experience to get good at debugging. It's a skill. It's part knowledge, part intuition, part kind of just problem solving. And it just takes time and experience to get good at it. One way you can practice is introducing your own bugs. Try to break your code in ways and try to predict what's going to happen when you break it. Basically what I just did, right? I de-indented part of my code and I predicted, I think it's going to do this. It actually did that. So that helps me understand the fact that if I did that error, I wouldn't get an error message for one, but I wouldn't get the code that I wouldn't get the result that I want. Yeah, and so it's just useful to kind of think about, help you learn more about the error messages and what will lead or won't lead to error messages, and essentially just kind of what mistakes you might or might not be making. So try and break your code and try to see and try to predict how breaking it will affect your code. In general, so you're all going to have bugs sooner or later. It's going to happen. What you should do is spend some time trying to figure it out and fix it. The process of racking your brain a little bit and trying to fix it is an important one. So definitely don't skip it. Don't go straight to asking for help. However, do not spend hours. One, it'll frustrate you and make you hate programming, which is not the point. And it's just not useful. So what you want to do is spend some time, turn your mind to it, have your brain gears kind of churning through, trying to figure out something, and then at some point knowing when to be like, okay, I'm not getting anywhere with this, I need to ask for help. That's a good skill to have, knowing when is a good time to stop. So definitely you want to spend some time figuring it out, but don't go crazy. At some point ask for help. That's a lesson here. Yeah, and definitely by all means, you can get help on Slack, you can get help on email, you can get help on office hours. There's a lot of, and the tutoring center, there's a lot of places you can get help. By all means, access all those resources. That's what they're there for. Don't feel shy, don't feel bad about asking for help. Learning to code for the first time is a hard thing. Ask for help, get support, do what you need to do, especially in these early weeks where we're laying down the foundation. You want to lay down this foundation solidly so that afterwards you can build on them more easily and everything will become harder. Like, this is just a tough part of this is like the steep learning slope part of it. It gets easier, trust me. All right, so a quick note on exponents as well. So I talked about this a little bit earlier, but about how Python does math, but this is a specific note on just exponents. So in math, if you have x to the y to the z, the way that it would process this is exactly like this. It would do 3 to the y to the z, and then 2 to the whatever the result of that is, and so you get 512, right? Python does the same thing, right? So if you do this, if you write it out like this, which is basically writing out this, you'll get the same thing as you would expect in normal like math. The only reason we're printing this out is because Excel does this differently, where if you do x to the y to the z, it will actually do the x to the y first and then put that to the z, which for whatever reason Excel does that way. That's fine, but that's not how Python does it. Python does it the way that math does it. And so just kind of be aware of those discrepancies. It'll be useful. It'll come up. And as always, if you're not sure about the order of operations, just use parentheses. No shame in that. If you want to be 100% sure that this thing gets done first, put it in parentheses. Just make it easy on yourself. All right, so a quick review on terminology. A variable is a name that refers to an object. So we're basically just creating an object and giving it a name, and that's what a variable is. Here we're creating an object called size. We're giving it the name size, and we're assigning it the value 200. Here we're creating an object, a variable called Tallulah, and assigning it a object of type turtle to it, right? A parameter is a special type of variable that's used by a function in the function definition to refer to argument values that are passed when the function is called, right? So we've talked about this at length, the difference between parameters and arguments. Parameters are only in the function definitions, and basically when you call a function and you pass an argument to it, the parameter values will refer to / take on the value of the arguments that are being passed to it, right? Arguments are objects passed to an object, or object passed to a function, and they can be variable or literal. So you can pass either variables or literals. That's fine to when you're calling a function. Your function definitions, your parameters, they must be variables, right? And logically, it doesn't make sense to pass a literal as a parameter. It just wouldn't make any sense. There's no point to it. Its entire function is the fact that it's a variable that you can change it each time you call a function. If you have it be a literal, you can't change it. It's not flexible, so there's no reason to have it as a parameter. So we talked about this in the last lesson. The scope, when we're talking about, essentially, it's useful to think about kind of from Python's point of view, what it knows about and what it doesn't know about, what's visible or not visible to it at different parts of the code. And And so parameters are only visible within their function definitions, right? So when you define the function, you're setting up parameters, and those parameters, for example, a turtle and side length, are only visible within that function definition. The variables that are defined within, variables defined within functions are only visible to Python within those functions. So meaning that main's variables are only visible within main, square's variables are only visible within square, right? And square's variables, when you're defining square, would in fact be those parameters, right? Yeah, and by visible, we just mean that Python knows what object you're referring to, right? So if in square you're using a turtle as your parameter, and you try to if you try to just use the variable a turtle in main without having it previously defined it anywhere else other than in square, Python won't know what you're talking about because it's not visible to Python in main. All right. In the for loops in the previous lecture, we talked about how we can use a size variable for a house so that we can update just one variable when we want to change the size versus updating all the measures, right? So this is essentially, this is kind of basically kind of with an example of what we meant. So you could do your house this way, where you're basically having, your house and your is making it a house that's 200 and moving by this distance, and then making a house that's 150, right? So that's one way you could do it. However, what you could also do is, for example, you could just set up size is 200, and then you basically have your make a house of that size, move, and then have her make a house that's bigger by 1.25, by a factor of 1.25, move, and then make a house that's 0.75 of the original house, right? And so these two codes are identical, or they're not identical. They will provide the same result. So you'll get three houses of the same size and the same everything with these two bits of code. Except here, you can just change this 200 to, for example, 100, and then the relative sizes of each of the following houses will be changed accordingly. So it'll be 100, 125, and then 75. And so you'll have the same relative different sizes, a big, a small, a medium, big, and small house all drawn together by Yordle, right? Instead of having to change three different numbers here, you can just change one number and everything else will change downstream from it. Again, you want your code to be nice and clean and simple, and so this is one way that you can make that happen. So once again, revising, we talked about this, I think, in the first week. In Python and many other languages, the equal sign is the assignment operator. So it doesn't mean equals to, it means we're assigning this to that, right? So here when we're saying size equals 200, what we're effectively saying is create a variable called size and assign to it the literal value of 200. So size gets assigned 200. That's what that means. When you use the size afterwards, for example, y equals size divided by 2. Oh, that should not say that. So size should refer to 200, not 30, or size points at 200. So what this means is that so effectively size here is a placeholder for 200, right? So if we say y equals size divided by 2, size refers to the value 200. And so this is effectively the same as saying as y equals 200 divided by 2. In other words, y equals 100, right? You can't use a variable before assigning something to it. So obviously, if you're in your main and if you just say size and you haven't previously said size equals to something before that, you'll get an error saying size is not defined because you haven't created the variable, right? When you're assigning literals to variables, you are assigning a value to it, but also creating it at the same time. Once it's created, you don't need to recreate it again. And if you reassign something to the same variable, it basically squashes, erases, replaces the previous value. And we'll talk about that in a second. So looking through some code, this is what we're seeing here. So x equals 100, you're assigning the value 100 to the variable x and creating the variable x. Then you're saying x divided by 2. And so this, you're not actually changing the value of x, right? X is still going to be equal to 100, and you're just saying, what's x divided by 2? What's 100 divided by 2? The answer is 50, right? So this 50 doesn't get stored anywhere. It doesn't go into a variable. Nothing happens to it. It's just Python's telling you your variable x divided by 2 is equal to 50, right? You could also say, for example, x is equal to hello. You could a string object, and then the variable x gets assigned the string hello. And so x here is no longer equal to 100. It's now equal to hello. And so if you just print out, if you just type in x, you'll get hello, which is what the value of x is currently, right? All right, literals. Literals are the actual values, not a variable, as represented in the programming language. So we've talked about this at length already. Variables refer to a value. Literals are the actual value themselves, or they don't have to be stored in a variable, but literals are values, and then you can store literals in variables if you want. Right, so too long don't read. Variables refer to values. Literals are values. And you can store literals in variables. All right, so over here, if we're again working through what this means, we're saying we're creating a variable called x and assigning to it the value 100. Then we're creating a variable called y, assigning to it the value 50. And then we're saying x equals y. And so what this means, if we understand correctly, is the variable x now will have assigned to it the value of y, which is equal to 50. And so x should be equal to 50, which it is, right? And then here, if we change the value of y to 99, x is still going to be worth 50. It's still going to have the value 50 assigned to it, because when you say x equals y, it's not a forever thing, right? It's not x is always equal to y. It's just saying x is equal to whatever y is equal to right now, right? And at this point in the code, y is equal to 50, so x is going to be equal to 50. If you change the y value after that, it doesn't matter anything. It doesn't change anything to x. It only changes the value of y. If you wanted x to now be equal to y again, you'd have to do x equals y here, right? Okay. Right, so same thing over here. If you create and define a value, you create a variable called y, assigned to it the value 50, create a variable called z, and assign to it the value 1, and then you say x is equal to y plus z. What you're effectively saying is x equals to 50 plus 1, right? Because y refers to 50, z refers to 1, and so x should be equal to 51, which it is. If, again, you change the value of y and z after the fact, it changes nothing to the variable x, because x is equal to what y and z were equal to when you did this line of code, right? Changing the value of y and z doesn't change anything on the after the fact. This is just a one-off operation. It changes the value of x, and then x stays the same until you reassign something to x, right? Okay, for loops. So this is an example of a for loop in Python. And so we talked about this in the previous lecture, but I'm just going to talk about it a little bit more, kind of what this all means. So we did talk about how. All right, so this for loop, essentially what we're saying is we're saying create a for loop and iterate through it 4 times, because we're just saying for I in range 4, right? So we know that, and we didn't worry too much about what all this meant, but essentially that's what we're saying. And so we know that it's going to run through these lines of code 4 times, 4 iterations of this. I over here, if we dig into it a little bit deeper, I over here is a variable that we're creating, and it's a special kind of variable. It's a loop control variable is what we call it. And so the question is, what is I going to be equal to? What or not equal to, but what is being assigned to I? What is the value of I, right? So we'll take a quick detour to answer that question, and we're going to talk about the function print. And so when I was talking about earlier, when I was talking about indentation, I use the function print. It's one of the most common functions that we use all the time in coding. It's a really useful function for debugging. And print essentially just spits out whatever you tell it to print, right? So if we say print 100, you put in the code print 100, and it'll throw out the characters 100, right? You say print high, it'll spit out high. If you print 100 high, it'll spit out 100 space high. so on and so forth, right? And print essentially means print to the terminal. So it basically is a way of like print to the terminal, print to the screen what you think is going on, right? Or not what you think is going on, but what we tell you to print to the screen. So it's basically show me this, right? So print is show me 100, show me high, show me 100 and high, show me, 100 high, 3.14 pi, whatever. That's what it does. And essentially, so you can put as many parameters within it as you want, and as it'll print it out, it'll basically put a space between each of these parameters. Right. So same as we were just saying, so you can also print out a variable. So if we create a variable called name and we assign to it the string Ziggy, and then we do print name, it'll print out Ziggy, right? Because Ziggy name refers to Ziggy, and if we say print name, we're referring to if we're doing print name, we're printing out the variable name, which refers to the string Ziggy, which is what it's going to spit out. If we do print hello name, it should print out hello Ziggy, right? Because here again, this is a variable. And if we do print hello and name within quotes, it'll actually print out hello name and not hello Ziggy, because here we're not printing out the variable name, we're printing out the string name, right? The variable name is a variable that refers to a string Ziggy. The string name is just, it's a literal string with the character's name in it, the word name in it, right? Yeah. All right, so back to our for loop. So so if we did this, for example, so if we did a for loop going through iterating through 4 times, and we just say print I, show me the value of I, what value is associated with I, this is what it would spit out. It would be 0, 1, 2, 3. And effectively, what it's doing is range 4 is basically telling yeah, all right. So essentially, Python is creating a variable called I, and you can here we're calling it I, and it's just kind of a convention. Often we use I, JK, whatever, as disposable variables that we can reuse. But they can be whatever you want to call it. That's totally fine. But here in this case, it's creating a variable called I. Then behind the scenes, I is basically doing it's assigning the value 0 to I. Then it's going to execute the code. So here print I, right? And so print I now refers to 0, so it's going to print out 0, which is what it does. And then it's going to go back to the top of the loop, and then it's going to reassign the value of I to the next value, which is going to be 1, right? So range 4, if we remember, range 4 basically produces a series of numbers going from 0 to the parameter here -1. So here range 4 will produce 0, 1, 2, 3, because it's right side exclusion. Right, and so I is going to have the value going from 0, then 1, then 2, then 3, as it iterates through the loop one time after the other, right? Yeah, and it'll basically do this 4 times until I is equal to 3, and then it'll close out the loop, right? And so I here is going to be equal to whatever we tell it to be equal to here. This can be a series of numbers. And so we're saying go through the for loop, have a variable called I equal to whatever whatever series of things we have here. And here this series happens to be numbers going from 0, 1, 2, 3, right? And then within the for loop, we're saying print whatever the value of I is at that point in time. And so this is what it's doing. The first iteration, it's printing the value of I, which is 0. Second iteration, I is going to be equal to 1. Third iteration, I is equal to 2. Fourth iteration, I is equal to 3. All right. Okay. Actually, so one quick small note. So earlier at some point I mentioned that print is a really useful function for debugging. And this is sort of an example. If you're going through your loop, and the loop is sort of a black box, you don't really know kind of what's going on inside. But using print allows you to kind of get a glimpse into what's going on inside the for loop, right? So here I know this is what's actually going on. And so the print can be really, really helpful for kind of printing out to the console kind of what's going on behind the scenes within your script, right? So yeah. Okay, so yet again, indentation is important. Notice the indentation, the for is indented within the function definition, and then the things that you want to happen within your for loop are indented within the for. The return is only indented once, and so it basically belongs to the function definition, which is where you want it to be. You don't want it to be indented twice because it actually doesn't belong to the for, it should belong to the function definition, right? So why is it useful to have a variable I that takes on different values, right? So intuitively that might not make a whole lot of sense. So why do we care? Why do we need this? But the truth is it can actually be useful, or it very often is useful. Um, right. So um, so for example, so here if we read this code, we have for I in range 36. So this loop should loop through 36 times. And then we're basically saying square yurtle 200. So it's going to make a square of 200 by 200 pixels. And then it's going to move yurtle to the right by 10 pixels, right? And so this should basically just basically a line of 200 pixel boxes all lined up next to each other, separated by 10 pixels each, right? Okay, so that's that. However, if we did this, for example, if we did for I in range 100, so this loop is going to iterate 100 times, and then we're saying have yurtle, we're calling the function square, so make squares using the turtle yurtle, and have the squares equal to size I, and then move to the right. So up here, what we had is 36 boxes of equal size, all 200 pixels by 200 pixels, all next to each other, right? Down here, because the size of our square is equal to I, and I is going to change value during each iteration, essentially what we're going to have is we're going to have a series of boxes going from size 0 to size 99, all lined up next to each other, right? So it allows you to have a consistently varying size of squares, which in and of itself is maybe not so useful here, but that's kind of one way that you might want to use it, or an example of a way that you might want to use it. Right, so this is basically what I just said. For each iteration, I has a different value. So square I does something different at each iteration. So you'll have a different size box during each iteration, a progressively bigger and bigger and bigger box until you get to a box of size 99. All right, so what if we did this instead? So basically this is the same thing, except we're doing I times 5, right? So again, if we think about this, as we're going through the first iteration, I is going to be equal to 0. And so 0 times 5 is 0. So you're going to have your first box is going to be equal to size 0, and then yurtle is going to move. Second iteration, I is going to be equal to 1. And then here you're going to create a box of using the turtle yurtle of size 1 times 5. And so your box will be 5 pixels by 5 pixels, and then yurtle will move. And so here, instead of having 100 boxes that go from size 0 to size 99, you're going to have 100 boxes that go from size 0 to 5 times 99, which I'm not going to do right now. Yeah, don't worry about it. 5 times 99 by 5 pixel increments, right? So you'll have a box of size 0, size 5, size 10, size 15, size so on and so forth. Right, so you can basically apply math to the value of I, which is again a useful thing to do that will come up as we continue in the semester. All right, so like I mentioned, your loop control variable doesn't have to be I. It can be whatever you want to call it. So you can call it master control, and then you do 5 times master control, which is the same thing as saying in the previous example, 5 times I, if if you're doing for I in range 100. 5 times I is the same thing as for master control in range 100, 5 times master control. So again, it's just some sort of convention. Those IJK, they tend to be variables that are reused, and so we kind of know to not use them for anything important or permanent, because they're just these variables that are often used in loops, and so they're kind of like throwaway variables that you don't use for anything else, so you don't get mixed up. But again, you can call them whatever you want, and oftentimes it's useful to actually call them something more that's more of a informational, that has more information than just I. All right. So last thing I want to talk about in this lecture is string concatenation and repetition. So you can apply math in quotes to strings, but it doesn't do exactly the same thing as it does with numbers, obviously, because they're strings. So one thing you can do is you can add strings together. So if you have, for example, a string 1 called I heart and a string 2 called rocket, and then you do string 1 plus string 2, it'll actually write I heart rocket, right? And the addition implies a space between the two, right? So same as print, that's essentially what print is doing. Print is doing the first parameter you pass plus the second parameter plus the third parameter, so on and so forth, right? You can also multiply a string by an integer with the multiplication, and essentially it'll just repeat that string over and over again. So rocket times 4 is going to be equal to a new string called rocket, 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 rocket. Right, and this is called operator overloading. Okay, so more examples. So for example, you could create a string called that contains the dinosaur plus a space plus ate the man, right? Yeah, actually, that's a good. Yeah, actually, so I'm sorry. So the plus actually doesn't include a space by default. Here, you see there was actually a space added here, which is why you have a space here. So the plus actually doesn't introduce a space by default. You actually have to do it yourself. Sorry about that. Again, different languages do things differently, so it's hard to keep track sometimes. All right, so as I was saying, the dinosaur string is going to be equal to a string containing a literal string containing the dinosaur plus a literal string containing a space plus another literal string containing ate the man. And so string is going to refer to the dinosaur ate the man, right? Because this and this are effectively the same, right? And so what you can do is you can even add more onto the string. So if you want to say string plus while he screamed, then string will now be equal to, well, if you do string equals string plus while he screamed, so you're assigning a new value to your string variable. The string variable will now contain the dinosaur ate the man while he screamed, right? And so you can actually reassign a new value to your variable, including your current variable, right? So you can actually do string is equal to string plus something else. So you could do like x is equal to x plus 2, right? And so you can do that. That's totally fine. And you can do the same thing with strings. Yet other examples. Right, so another thing that can be useful. So the \n is essentially a line break or escape sequence. So if you here, this is a string that we were at before. Strings equal, or string has the string. The variable string has the string containing. The variable string refers to a string literal containing the dinosaur ate the man while he screamed. So that's one thing. And so if you wanted to, you could do string plus \n. It was gross \n, and now your string is going to be equal to this, right? And here this looks weird because you have these weird \n's in your actual string. But if you print string, so string it refers to this literal value, right? But if you print it, the print function actually knows that \n means change line. And so it'll replace these \n's by actually breaking line and putting it was gross on a different line. And then it'll actually change line over here also, which is why you have an empty line space over here. Right. So here essentially what we're saying is string equals string plus something else, right? But a shorthand way of doing this, you can actually do string plus equals I like it, which is the same as saying string equals string plus I like it, right? So this is just a shorthand way of saying this, which is because we actually often tend to do this, basically just tacking on extra strings to existing strings. That's something that happens a lot. So this is a shorthand way of doing this. And so now our string, which used to be equal to the string, the dinosaur ate the man while he screamed, break line, it was gross, break line, is now going to be equal to all of that plus I liked it, break line. And so if you print that out, the dinosaur ate the man while he screamed, break line, it was gross, break line, I liked it, break line, empty line, and that's our result, right? Okay, so that is that for this lecture. Hopefully all of that made sense. And once again, just make sure to check out the tutorials. I know that this is a lot of this, at least for me, a lot of the kind of theoretical kind of going over these concepts is fine, but for me, actually doing something with it is where it really solidifies for me. So make sure to look at the tutorials where I live code and use all this stuff and put all this stuff in practice, and you can code along with me. So I will see you then, hopefully in the tutorials.